Hello, welcome to another lecture in advanced networking. In today's lesson, we are going to be looking at device discovery, management, and maintenance. So, this discussion is going to be largely focused on, as always, the CCNA course, but the concepts that we would cover today can be translated across devices that are from different vendors. So, even though the concepts that we will study based on Cisco devices, the concepts should be translatable across other types of devices as well. So, as with any other concept that we have covered in the previous lessons of this course, the same thing applies here as well. So, when we look at device discovery, management, and maintenance, the things that we are going to be mainly focusing on when we have a larger organizational environment, a larger network environment with multiple devices interconnected, say for example multiple routers and switches that are connected in the network, and then we need a way for these devices to, couple of things need to happen. These devices need to talk to each other to understand the larger network, so they may use certain protocols to share information between them, come to sort of a common understanding of how they are going to communicate, so what protocols to choose and so on. Then from an administration point of view, we may want to communicate with these devices, we may want to make changes to their configurations and also update the software, update configurations and so on. So these are some of the things that we'll be looking at in today's lesson. So we'll first start with device discovery. So when we say device discovery, the main thing that we are doing here is how different devices can pass on certain messages to know about each other. So one of the protocols in the Cisco realm is the Cisco Discovery Protocol, or CDP. So this is used to as a sort of a layer 2 protocol for devices to send information back and forth between these devices, and they can make sure that those devices are still connected. So they will share the information about the devices that they are connected to, name of devices, the interfaces that they have, and all these things can be shared across all the devices in the network, and then using that, these neighboring devices can also build an information about the larger topology. So for example, if we start with 2 devices and then they are connected to these number of devices, if they can share that information, now both the devices will have the understanding of this larger topology. So CDP is a useful protocol in many ways. It can share this information, but there are certain situations, we have touched upon this previously as well, that in some situations we may want to disable CDP because it may inadvertently give out information to parties that don't really need them. So it may be a security concern. So it is a useful protocol and we may use them in certain situations, and we may disable that in certain other situations. So the basic way of configuring CDP is fairly simple. We just need to, it is by default, it can be enabled or it can be there. But if it is not enabled, we will use what is called the CDP enabled command, and we can enable that, or we can use the no CDP run command to disable that. So we can do that per interface. So we can go into each interface and specify whether something is enabled or disabled, or we can do it in a global manner using the CDP run or no CDP run command. Once CDP is enabled, then we can go and see information about various neighbors and other interfaces. So we can see all the details of various things that are learned from the devices, learned from the CDP protocol. So the information that has come and gone shared using this protocol can be displayed using this command. So when we use show CDP neighbors, it will show the various devices that are directly connected to it. So for example, it will show a device, so the device name or the device ID, and then in addition it can also show what is the interface that it is connected to, things like hold time. It can also identify the capability codes to say whether it is a switch and so on, whether particular protocols are enabled on them, what is the platform or the version and so on. So various things can be displayed as part of that. We can also use the show CDP neighbors detailed command to get more detailed information about that. So when CDP shares this information, the information is going to be about a lot more detail. So the versions of software and everything is going to be part of that. But we may either see a summary of that, or we may look at all the details of that. So this can be used as we require. So for example, say if we do show CDP neighbors on S1, S1 has information about S2 and R1. So this is S2, this is S2, and this is R1. So those are the information S1 has learnt about. Once S1 is sharing that information with S2, now if we go to the same command in S2, now S2 has information about S1. So now all the discovery has been completed. So R1 is there, S1 is there, S2 is there. So that is basically how we would discover devices using CDP. So CDP is a Cisco specific protocol, only implemented in Cisco devices. But when we think about larger networking environments with devices from various vendors, we may need to use a vendor neutral protocol for this purpose. So that is the link layer discovery protocol, or the LLDP. So this is fairly similar to CDP. Here it can again discover routers, switches, wireless LANs, and all these things. So all these devices can be done using this protocol as well. So CDP is a Cisco specific protocol, and LLDP is a vendor neutral protocol. Similarly, in terms of configuring LLDP, we can use similar commands to do that. So we can use the LLDP run or no LLDP run command to run and disable them globally, or we can use the LLDP run to particular interfaces, and then we can go and see whether they can do LLDP receive, LLDP transmit as well. So then if we use the show LLDP command, it is again going to show how other configurations are done in that. So in terms of discovery, it is going to be fairly similar here as well. It is going to say, if we go into switch 1 and use LLDP neighbors, it is going to show R1 and S2 as the neighbors. So again, we can do the LLDP neighbors detail to see what are the more detailed descriptions of those learned devices. So now let's look at some of the things that we can do in terms of device management. So when we think about device management, one of the basic things that we would do is setting system clocks. So as with any computing device, routers and switches and all these active network components are computers as well, and they need to keep up a correct, accurate sort of time signature so that all these network communications can be accurately done. So because the time is a significant aspect of that as well. So they need to have a proper clock information setup. So there are two ways we can do that. One is we can go and manually configure the clock. So we can go and set the clock to a particular date and time. So that is one way of doing that. And the other way of doing clocks is what we call network time protocol, or NTP. So with NTP, what we have is a set of servers that are going to provide time. So these are sort of hierarchical set of clocks. So we have certain clocks that are at the higher level, and then there are some servers at different levels, and then we may connect to some of these NTP servers to get the accurate time as we need. So we can have multiple layers of these NTP clocks. So then if you want to configure NTP clocks instead of manually configuring clocks, what we can do is we can do configure a particular NTP clock. For example, we can go and specify a particular NTP server. So we can go and specify a particular NTP server to say from where it is going to take time. So, and then if we go into show clock detail, it is going to show the time as time is coming from NTP. Otherwise, it will be showing the time is coming from user configuration. So if we manually configure it, it will come as time is coming from user configuration. If we use NTP, it will come as time is coming from NTP clock. And then we can do additional checking in terms of verify whether NTP associations are correct to see if we are getting time from the correct server as we want. So we can do those things as well. Then when it comes to device management, another thing that we will come across is logs, because in various devices we will generate so we can create logs of every action that is happening in the devices, and we can store those logs. But one of the troubles with like having logs in various devices is it may not be easily accessible when we need them. So one of the approaches that can be used is what is called a Syslog server. So what we can do is, instead of saving these logs in these individual devices, we can have a centralized server that is going to be used as a Syslog server. So that centralized server will be used to store any log messages that are generated from various devices. So Syslog is a standard protocol that can be enabled in various devices, and these devices can send messages to the Syslog server, and the Syslog server will log them as log messages. So there are a number of things that can be done using Syslog. So one is it can be used to gather information for the purposes of monitoring and troubleshooting. So various devices can send information to the Syslog server, and that can be used for the purpose of monitoring and troubleshooting. We can, in Syslog server, we can select different levels of messages. So messages can be specified at different levels, and they can be, certain messages can be captured, certain messages can be stored. And another thing that can be done is certain type of messages can be sent to different servers as well. So we may use a number of different Syslog servers for different purposes, or maybe certain warning systems and so on. So we can have number of destination as well for these captured syslog messages. So the syslog server may be able to redirect them across to different services. So when we look at syslog in operation, the syslog protocol normally starts out by sending logging messages to sort of any sort of devices that are attached to that. So we can have either we can have a local logging buffer, so a local storage where we can have this information. If we connect some devices using, say, console line, so if we are connected through direct console connection to the switch, for example, the messages can be displayed there. If we are connected through other terminal connections like an SSH terminal or something, again they can be displayed there, or they can be forwarded onto a syslog server. So the same messages can be going into a number of these devices or number of these destinations as we need. And particularly the way, if we are configuring like an external syslog server, that can be a lot more useful because those information can be used by various other systems as well. They can be used for reporting purposes, other system analysis purposes, and so on. So that is one of the reasons why we may use this centralized or external syslog servers. So in terms of the syslog messages, there can be a number of levels of these messages. So not every message is going to have the same level of severity. So there can be certain emergency messages, certain can be something like informational or debugging messages that are not so critical, but whereas emergency or alert messages can be much more important, the severity can be higher. So some of these things may be sent to different destinations, and some of these things may be sent to different destinations depending on the nature of the messages. So some may be recorded for future reference purposes, but whereas a critical alert or emergency message may be sent to a monitoring system for someone to attend to that at the particular time, within a particular time period. One of the other things that we may need to do is, by default, these log messages are normally not timestamped. The problem is, if the log messages are not timestamped, they are not much useful to us, because when they get stored, we may not know at what time they were generated, and we may not be able to refer them back to a particular event in time. So we may have to specify the timestamp also with the messages that are being sent to the log server or the syslog server. So we can do that using this particular command of service timestamps to be included in the logs. So using that command, we can specify that these log messages, the messages that are sent to the syslog server, are also including the necessary timestamps. So by default, loggings are normally sent to the console interface. So we can go to the console interface and view any sort of log messages that are being received by using the show logging command. So that is by default, it will be displayed in the console output. Now we will also briefly touch upon some of the things that we will have to do when we are considering device maintenance, particularly in the case of sort of updates and so on. So as with any sort of active devices on the network, switches and routers are also can be considered as uh, computing devices, and they will have their own file system. So they will have certain files stored, and they will have certain file system structures and so on. So we may go into, say, for example, do any sort of operation that you would do in any typical file system, sort of reading files, removing files, changing certain properties of files and so on. Some of those things can be done as we would do with any typical file system. So we may use certain different partitions, maybe there are different type of files, maybe there are, so we may be able to view them, and sort of maybe sometimes we can copy them across to the local networks or other devices and so on. So these are some of the possibilities that we will have in terms of these file systems. So we can use the standard sort of directory command to list all the files that are stored there. Standard commands like present working directory and so on are also supported in many sort of router configuration interfaces. So here we can go and see who has access to the files, the details about the files, file names and so on can be viewed there. So typical change directory commands and so on will also be used here. One of the things that we can do is, for example, if we have certain configuration files, we can copy those configuration files across FTP. Say, for example, we can download those configuration files into our own devices or copy them across to different devices. So we may connect to a different server, an FTP server, for example, and copy files across to that, or we may copy them to our local device from which we are connecting to the switch or the router. So this can be used as a way of backing up configurations and copying them across to different devices, or backing up and restoring for as a backup purpose. In certain devices, one of the things that we may encounter is we may have certain situations where the password of the device may have to be reset. So we may have to go and reset the device and reset the device password, and we will have certain configurations for those as well. So we may have to restore a particular startup configuration, and we may have to reset the password as necessary. And one of the common things that we may do is, in terms of backing up these configurations, is we can, instead of saving the backups on the device itself, we can set up a remote server as the backup destination. So whatever the configuration files can be backed up to the server, and we can also restore from the server if needed. So this either it can be backed up to another router, another server, or a workstation somewhere else on the network. So anything, if this router fails or if this device fails, we may be able to still get the configuration and load it onto a different device and continue running. So there can be a number of reasons why we may want to do this type of remote backup. So instead of only having backups on the local flash storage, we may also store the backups in these remote devices. So once we, for example, once if a device fails and we may want to copy them again, we can go back to the remote server and we may find that file and we can copy that back onto the device again. So that is a use that we will have when we are using this type of remote backup service or backup systems. So if we have, for example, updated our device, so we would have copied a new system image to update the version of the software, then we can do a boot system command. We can do the boot system command and also copy the configurations again. And if we do that, that is a way to update the system. So updating the system is also something that we will have to do a lot in maintaining these devices. So as a summary, what you need to understand is we looked at three things today. One is device discovery. So there are a number of protocols like CDP or LLDP to enable devices to learn about each other. This is a useful feature, so they can understand about the topology, but also they share a lot of information when they are sending this information across the networks. So it may also be a security concern. So depending on our requirement, we may enable or disable this in our devices. Then there are a number of protocols in these devices to help them function better. So things like NTP protocols to learn about time, or Syslog to share log messages and so on in sort of medium to larger networks, so they can be shared, or the log messages can be saved in these log servers and so on. And then we may have to, any type of active network components, we may have to maintain them. We may have to save their configurations, back up their configurations, so we can restore them when devices go bad, or we may need to update their systems, update their underlying operating systems. So all these things we will have to consider in addition to our main configuration of these devices that we have covered in the previous lessons. So this is also an important part that you will have to consider when we are maintaining significantly larger networks. Even for smaller networks, this is an important concern, because up-to-date network devices and so on are very important for us having secure and stable network environments. So that's all we have to cover in this lesson, and this concludes our set of lessons in advanced networking. And as always, you can refer to LMS for relevant additional learning materials and practicals and everything else. And you may contact me with any questions using your standard communication means. And until we meet in another course, thank you for joining in this advanced networking course, and thank you for participating in all the lessons. See you at another course. Thanks. Bye.